Hello everyone, welcome to another video in my channel. In this video, I will be solving with you practice test, standardized test, grade 10, chapter 5, circles, mathematics. So let's start by the first question. So it will be talking about the pools. Amal's family has a swimming pool, and this swimming pool will be having depth of 1.3 meters, and the diameter will be given for you as 7.6 meters. So he's asking you about the circumference of the pool to the nearest meter. So pay attention. Whenever he's asking you about the circumference, then you can just put the formula C is equal pi d, or you can use 2 pi r. Since he's giving you a ready value, which is the diameter, so you can just use it directly. Pi multiplied by 7.6. After calculating it, it will be around 23.87, and if I would like to have it to the nearest meter, that means it is around 24 meter. Great. Now let's go to the other question, which is a bit tricky. Find the exact circumference of the circle. So he gave you a circle which is inside another polygon. That means this polygon, which is the square, is circumscribed by this circle or about this circle. So let's think of it like you are having each side of the square as 32. That means whenever you are walk or you moved with your ruler, you will be getting your 32 all over this square. So let's move until our center. That means even this segment will be having measurement of 32. And we call any segment passing through the center from the one side of the circle to the other side as a diameter. So your diameter will be 32. Now easily you can find your circumference. So it's all about pi d. I'm so sorry. So it's all about pi d, 32 pi, and he wanted from you the exact circumference, so no need to round any value. That's it. Now let's go to the other questions. 3, 4, 5, 6, they want you to find the value of x, but each case will be different. So let's look now at this circle. First of all, he gave you the measurement of this angle in an indirect way as right angle. That means you know that this measurement is 90. And he gave you this measurement to be 67. And he's asking you about this measurement. So let's focus together. If you concentrated, focus on the diameter itself. Over this diameter, you will be having your semicircle. That means all this circle, the total angles inside this semicircle will be having 180. So let's go to question 3. How can I solve it? You need to imagine that the summation of all these angles will be added to 180 because we are having here semicircle. So let's focus x degree plus 90 degree plus 67 degree equal 180, which is the angle addition property. Like terms, move them to the other side, and you can get your x degree to be 23 degree. That's your question 3. Now let's go to question 4 and pay attention. What's your x? So this time he would like your x to be this arc, and he didn't tell you what's the measurement of this angle which is related to this arc. He gave you the measurement of the other angles. So here you are having 90 degree, here you are having 65, here you are having 110. You should know an information that the summation of all the central angles inside a circle will be added to 360. So first of all, to know the measurement of this arc, you should know the measurement of the central angle opposite to it or related to it. That means all these angles will be added to 360 and will be giving you the measurement of this angle. Let's call it 1. That means measurement of angle 1, it's all about 360 minus the addition of all of these, 90 plus 65 plus 110, which will give you a measurement of 95. Now let's focus on one thing. Whenever you are telling me to get the measurement of any central angle, then the corresponding arc will be having the same measure. That means your x will be equal to the measurement of this central angle M1, which is 95. That's it. Now let's go to question 5. And let's see what he's asking you to do. In question 5, pay attention to the units. He's giving you a circle, and you are having a sector, a radius, and an angle here. Then, what he gave you, he would like you to find x but in centimeter. That means he wants to have the length of the arc. So put the rule, length of the arc, it's all about x over 360 multiplied by 2 pi r. So let's focus on this. What's your L? Let me write it up. So that means it's all about 78 over 360 multiplied by 2 pi by 3, which will be giving you length of around 4.1 centimeter. Now let's go to the other question and pay attention to this question. So in question 6, he is asking you, you are having a circle. He just give you what will be this chord and what will be this chord. But he gave you very important information about the arcs. This arc will be congruent to this arc. So, according to the relationship between the chord and the arc, whenever you are having two congruent arcs, That means the corresponding chords will be also congruent. And whenever I'm saying congruent, that means they will be having same measure. So you must make the first chord equal to the other chord. So 12x minus 8 equal to 5x plus 13. And now you are having an equation with variable on each side. Solve this equation. 7x is equal to 21. Divide both sides by 7. X will be equal to 3. That's it. With this, you found the value of x, but each case will be different and having another concept. So pay attention. Now let's go to this tricky question. Multiple choice question. He's asking you, what is your ED? And he stopped. He didn't mention anything other than this. Then he gave you a circle and these two lengths 60 and 65. Now maybe some of you will be thinking that this is a semicircle. But how did you know? Do you have a proof? Did the question show you that this segment is passing through the center? You don't know. You are not sure. That means this question, there is no enough information. This can be solved in a way that if you are having your point or your DF on the center, that means this will be right angle triangle, and you can find this by the Pythagorean theorem. But for this, you cannot judge if it is on the center or not. For example, here we judged that it is on the center and it is semicircle because it was really shown on the graph. So let's go to the other question. Find x, question 8. Find x if circle M is congruent to circle N. So whenever you are having two congruent circles with having congruent chords, that means your arcs will be congruent also. So pay attention to this. If you are having congruent circles with two congruent chords, there is a relationship between the chords and the arcs. Whenever one of them is congruent to the other, then the chord will be also congruent to the other chord. And vice versa for the arcs. That means whenever I'm saying that you are having arc ST is congruent to arc UV, that means your measurement of ST will be equal to the measurement of arc UV. That means all what you need to do is that just make them equal. So what's your ST? 2x, and the other is 5x minus 27. So now you are having equation with variable on each side. You can just solve this equation by moving this 2x to this side and minus 27 to this side, and you will be having 3x equal to 27. Divide by 3 both sides, divide by 3, and easily you will be getting your x as 9. That's it. Now let's go to the other question. How many points are shared by concentric circles? So this, what do I mean by the concentric circles? What will be special about the concentric circles that they are coplanar? They are on the same plane and they will be sharing the same center. But they have no points of intersection. That means 0 points of intersection. Pay attention to this. Now, question 10. Determine whether FG is a tangent to the circle and justify your answer. That means all what we need to do is that we need to make sure if when we add segment FG, are we going to have a right angle triangle or not? And what's special about the right angle triangle is the Pythagorean theorem. So let's now focus on this. Whatever you are having, a square plus b square is equal to c square. But here we are still not sure, as I put a question mark. That means we need to test. If we add FG squared plus GE squared, am I going to get FE squared? So let's now substitute and check, am I going to get this or not? That means 26 squared plus 17 squared, is it going to be equal to 30 squared? Calculate both sides. All of these will be equal to 965. And this will be equal to 900. So are they equal? Ask yourself. No, that means they are not equal. That means they will not form a right angle triangle. That means your FG segment is not a tangent to circle E. And we justified your answer that it will not be forming, there is no right angle triangle. Good. Let's now go to this question, which is conceptual question. Pay attention. Which of the figures below shows a polygon circumscribed about a circle? So let me just explain this question. Whenever I'm saying a polygon circumscribed, that means this polygon will be about this circle. It will be around this circle. So you will be cancelling some of these answers. So let's now focus on these questions. Look at A. Is the polygon circumscribing the circle? No. It is inscribed. Now let's go to C. We are having a polygon outside and it is circumscribed. And what is the importance in this question is that each point or each edge should be a tangent to this circle. That means my C is right. Let's check the others. So here you should pay attention that, let me just maximize it for you. Here you should pay attention that you are having a gap. And this gap will not allow you to have a tangent. So let's look at this question. Here you are having the circle outside. This is one of the things. You are having the circle outside, which I don't want this. Other than this, there are many points inside. Good. Let's look to this question. Now, previously, what I told you here in this question, that what will tell me that a polygon is circumscribed about a circle is that it will be around a circle and each point will be touching the circle and will be forming a tangent on this circle. So let's go to this question. Find the perimeter of the triangle at the right. Assume, this is very important, assume that segments that appear to be tangent are tangents. That will be helping you because we are having our theorem. Whenever you are having a circle and you are having two tangents here, that means it will be having a tangent on each side. So let's draw this tangent. And whenever you are having an external point here, what we can understand about these tangents, that they are congruent to each other. So this will be helping you to solve this question and to find the perimeter. So let's focus on this question. Here, in this external point, so you can name these external points L, W, R, for example. So in this external point, you will be having two tangents on this circle. That means each tangent of them will be congruent to the other. That means if it is 14 here, then you are having 14 there. Now, let's go to this segment. We are having an external point of R. So it will be forming two tangents and each tangent will be congruent to the other. That means if we are having measurement of 9 here, we will be having measurement of 9 there. So let's focus on the segment addition. He gave you segment WR as 15 and you are having part of it only to be 9. So you need to know only this part. So focus what you will be doing. It's all about segment subtraction. You will be subtracting. So 15 minus 9. And pay attention whenever you are using this theorem that you need to focus. It's all about 6. So this is an external point. Let's go to the other external point, which will be forming two congruent tangent. So if there is a measurement of 6 here, that means it is 6 there. So let's now draw our new triangle. So I will roughly sketch it. So roughly sketch here, you know that the measurement is 15. There, you know that it's all about 14 plus 9. And there, you know that it's all about 14 plus 6. So what do I mean by the perimeter? It's all about the summation of all the outside values. So 14 plus 9 plus 14 plus 6. This is the second side. And lastly, the last side, which is 15, which is given to you already. So it will be 58 units. And now let's go to this question. Find each measure. Now pay attention to the difference between question 13 and question 14. What he's asking you in each question. So he gave you here a circle where you will be having two tangents and they are having an intersection point with an angle with a vertex outside. So you are having your angle with an intersection outside the circle. So pay attention. Here you are having intersection outside. So he's asking you about angle T. So you need to put in your mind the formulas of the intersection outside, inside, and on the circle. Pay attention. So here, all what you need to do is that you will be putting your half, and because, just give me 1 second, you will be putting your half, and because it is outside, then you just need to subtract. Good. Now, when you subtract, what you are subtracting already, you will be subtracting the intercepted arcs. So you will be taking your big arc, which is measurement of arc RQS, minus measurement of arc RS. Good. Now let's focus together. He already gave you the measurement of RS, and you are having a tangent which is touching these 2 points. That means it is only cutting the blue area. So how can you get the red area, which is the big arc? It's all about when you are having the total of summation of the central arcs, it will be 360. That means your measurement of RQS, it's all about 360 minus the measurement of RS arc. And when you subtract them, it is 360 minus 103. So it will be giving you a measurement of 257. Good. Now let's substitute. So your measurement of T will be 1/2, 257 minus 103. Now let's focus on one thing, which will be giving you measurement of T as 77 degrees. So let's go now to question 14. So in question 14, let me just duplicate this. So in question 14, you should focus on what he's asking you to do. He's giving you a circle, and you are having intersection inside the circle itself. That means you need to focus on the rules or formulas of the intersection inside the circle. But pay attention what is given to you. Does he need from you the rules of angles or the rules of segments? So it's given to you only the segment. So, and you are having two chords are cutting each other. That means this is all about theorem 515, which is segments of chords theorem, which will be telling you all about, just let me solve it here. So it's all about your BE divided by ED will be equal to AE divided by EC. So let's focus now on this. Your BE is X, your ED is X plus 10, which will be equal to X plus 1 multiplied by X plus 3. So now focus on how can we solve this question. So in this question, here you can solve it using distributive property. On this side, you can solve it using FOIL method. So let's pay attention to this. In this answer, after using the distributive property, it will be x squared plus 10x here after using FOIL method, you will be having x squared plus 4x plus 3. Then move all the variables next to the other. So x squared plus 10x minus x squared minus 4x equal to 3. That means here you are having like terms with opposite signs, and here you are having other like terms. You need to calculate them, which will be giving you 6x equal to 3. Divide both sides by 6, which will be giving you x as 1/2. Great. Now let's go to the other question, which I shifted to the other slide. Now question 15. So we are having the flowers question. Khawla wants to encircle a tree trunk with a flower bed. So if the center of this tree is the origin, so he gave you your center of the circle. It is the origin, 0 and 0, and you know the center is all about h and k. So she would like to extend it to have 3 meters from the center. So what do I call the measurement from the center to any point on the circle? It will be your radius. That means she gave you indirectly the radius. What is the equation that would represent the flower bed? That means they are asking you to write the equation of the circle in an indirect way. So let's now put the equation of the circle. In general, it is x minus h all squared plus y minus k all squared equal to r squared. So you need to pay attention whenever you are having a circle on the origin, your h and k are zeros. So directly you can write it as x squared plus y squared. So if you didn't know how can we get this, just substitute your h with 0, your k with 0. And then your r squared, just take the radius squared, it will be 9. That's it. This is your equation of the flower bed. So let me just separate. This is related to question 15. Now let's go to these questions. So these will you will be finding them in page 405, the standardized test. So I have selected some questions only from the standardized test, which is related to the circles. So here he's giving you a circle. And as I mentioned in the mid-chapter quiz, you can refer to the video if you didn't watch it yet. All what you have here is a circle, and they are having 2 angles, E and another angle. Let me highlight it with another color, which is angle F. And these 2 angles are called to be the inscribed angles. And when 2 inscribed angles are sharing the same end, that means they are sharing the same intercepted arc. That means they will be described as 2 congruent inscribed angles. Now let's further describe them. How can I solve the 2 congruent angles? That means I will be making their measures to be equal. So your 6x plus 2 is equal to 3x plus 23. Now you are having an equation with a variable on each side. Solve for x, so your x will be 7, which is your d. Now let's go to this question. You are having a triangle which is circumscribed about this circle. So the theorem of having a circle and an external tangent intersecting outside and 2 congruent tangents will be helping you to solve this question. So let's look at the external point. So the first external point, let's look at this. That means, first of all, The segments in green, they are equal to each other, congruent. That means your 3x minus 2 will be equal to the 10. So this is what I can get from the first part. And if you solve for this, you can get your x as 4. Now let's go to the other part. Let's check all of them. Let's go to this external point, R. That means you are having other two congruent sides. X plus 1 equal to 5. And if you solve it, you will be having x is equal to 4. Good. Now, you can take your x already, and this is congruent to the other. You can take your x and substitute with it. Now, if you substituted here, it will be 3 by 4, which is 10, which is the same value as this. So you can just cancel this and put it as 10. And you can cancel this and put it as 5. They just gave you these two to get x, so you can solve for this question. So you can just imagine that he didn't give you these. You just use them to get x. Now, after getting x, substitute here. So 4 minus 1, that means this is your 3. Now 4 minus 1, this is your 3. That means let's have a roughly sketch for the triangle. Here it is 5 plus 10. So it's all about 15. Here it is 5 plus 3. It's all about 8. Here it is 3 plus 10. So it's all about 13. Now add all of them to each other to get the parameter, and this will be equal to, so 15 plus 8 plus 13, which will be equal to 36 units, which will be your answer of G. Now let's go to this question. What is the value of x in this figure? So he gave you a circle, and each part of the circle will be performing an angle or a central angle for you. So you know that the summation of all central angles inside a circle, it will be 360. So if you added all these angles, you will be having 360. That means 360 equal to the summation of all of these, 3x plus 90 plus 7x plus 10. So he would like you to find x. Now you can solve for this equation. You are having like terms. So 100 plus 10x, you will be having 360. Solve this equation. You will be having 10x is equal to 260. Divide by 10 both sides. You will be having x as 26, which is your C. Now, let's go to this question. Now copy the circles below on a sheet of paper. Now I'm doing it in a laptop, so no need for me, but it is like a conceptual question that they can get it to you in the MCQ. They can draw it for you in a ready graph. So he would like you to draw the common tangent. So whenever you are thinking of a common tangent, you should think of something that will be tangent to both circles, not only one of them. So the first tangent, I can draw a line that is touching both of them, and at the same time another line touching the other side. And with this I can draw two of them. Now let's see how can I draw the others. So I'm roughly drawing. So this is tangent 1. This is tangent 2. Now let's go and see how can I draw the others. If I can join or take a tangent from this circle to the other circle, then that would be good. So that means I can connect, but let me just have it down a little bit. It is a thick line, but it will be good. Now let's go and connect between them to the other side with a tangent. This is what I call it with the common tangent. It should pass it through a point, one point for each circle. Now let's go to this question. You are having a square inside a circle with having each side of it 5 centimeters, and it is inscribed in a circle. So what is the circumference of the circle? To find any circumference, whether you need your diameter or your radius, so you need to get one of them. Always connect this inscribed square inside a circle to the idea of having a right angle, a triangle inside this square. That means you can just draw here a right angle triangle which is passing through the center and having a right angle here, triangle. So your diameter will be this, and each side will be performing 5 for you. So that means to find the diameter, what you will be doing is that you will be dealing as c squared is equal a squared plus b squared, which is the specialty about the right angle triangle. So your c square will be considered as your d already. So I want to find the d only, so I'll be taking the square root of e squared plus b squared. That means 5 squared plus 5 squared, which will be giving you 5 square root of 2. Or just keep it as it is for now, so you can later round for the circumference. Now to find the circumference, it's all about pi d, which is 5 pi square root of 2. Now you can round and take it to the nearest tenth of centimeter. It will be 22.2 centimeter. Good. Now let's see this question. He would like you to solve for x in this figure, and pay attention what is your x. You are having two chords are intersecting. That means it is the segment chord theorem, and you need to find your x. That means if you multiplied each part of the chord by the other, it will be equal. So x multiplied by 15 is equal to 10 multiplied by 12. And solve for x in an equation, your x will be 8. That's it. Now let's go to the last question in this video. Pay attention, it's all about the equation of the circle. Use the circle shown to answer each question. He gave you a graph and he told you what is the center of the circle, what is the radius, and what is the equation of the circle. So pay attention. Whenever you would like to have the center of the circle, you should know that it will be located on a point where you will be having equal measure from all the sides. So apparently it's this point where you will be having 3 steps every way. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that means you can just locate it. So this is your positive 1, 2, 3, 4, and this is your negative -1, -2, -3. So your center will be H and K, which is all about 1 and -3. And what's your radius? It is the equal measurement from the center and each side, so it is all about 3 units. And now if I would like to write the equation of the circle, let me just write it as it is. X minus h all squared plus y minus k all squared equal to r squared. So with this, what I will be doing is that I will just substitute. So your x minus 1 all squared plus y minus -3, which is plus 3, all squared equal to 3 squared, which is 9. That's it. So that's the end of the video. If you need any question, you can just type me a comment and ask me. Thank you so much for watching. I wish you best of luck.